Hello, David Snowpeck here from Snowpeck Games, and this is my third devlog in my crazy project to take Retro Tank Party from old Game Jam game to Steam release in only 6 weeks. What is Retro Tank Party? It is a 2 to 4 player online multiplayer game built in the Godot game engine using Nakama as the backend game server. I have been pushing so hard on this project. I thought I was exhausted last week. Well, this week I'm double extra exhausted, but I have made a lot of progress. First, some news. Steam finally accepted my build, and now I have Steam keys. I've been getting them out to beta testers to help test the Steam version. If you want to get involved in beta testing, join the Discord. There is a link below, and ping me. I'll give you a Steam key. We can shoot each other in tanks. It'll be a good time. Aside from that, I now have a macOS version, even a Steam macOS version. To make that happen, I had to figure out how to sign and notarize the build with Apple. So here is one of the pipelines on my Steam branch in GitLab CI. So basically the way this works is I make a change to the code, I push it to the Steam branch on GitLab, and then GitLab CI will first make the Linux, macOS, and Windows builds, the Steam versions of the builds. It has to use a different export template to have the Godot Steam integration. And then there's this new step in the middle, this macOS Steam step, which will do the signing, and then it sends the build to an Apple web service, which will get back at some point to say like, hey, we've notarized it, and then it gives you this little ticket, and you can staple the ticket to the app. They actually call it stapling. The command line tool is stapler, I think. And so far it's been working pretty good. Looking at this random build, it looks like it took about 2 minutes for Apple to notarize the app, and like 2 or 3 minutes seems to be about the average. Although I've heard some people say that occasionally they'll take like 5 hours to notarize the build, which would be really annoying if that actually happened. Like imagine you're fixing some critical bug and you want to get it out in Steam to help your users, and all of a sudden you have to wait 5 hours for Apple. But that hasn't happened to me yet. We'll see. But yeah, this is very interesting. So this build actually has to run on a macOS machine. I have this Mac in Cloud thing. So Mac in Cloud is a service where you basically rent a Mac Mini that's off in the cloud somewhere, and you can log in. I'm on like the pay-as-you-go plan, where I pay a certain amount for like every hour that I use the Mac, because I don't use it for very much. I have the GitLab CI runner on this Mac in Cloud, and when GitLab CI gets to this macOS signing build, it actually sends it off to this macOS machine, which then runs my script to do the signing and notarizing, and then it gets sent back to GitLab CI to then go on to the next stage in the pipeline, which is just a normal Linux Docker image to actually upload it to Steam. So I can make my commit, all the things happen, it's on Steam in about like 4.5 minutes. Like, how long did this actual build take? That was this one? Yeah, 4 minutes and 26 seconds, which is probably faster than I could do that if I had to do it by hand. Doing 3 exports and running a bunch of stuff on the command line for, Apple, and then going to the Steam tools and pushing it up. So I'm very happy with that. At some point, I'm going to make a tutorial about setting up the macOS signing and notarizing on GitLab CI. What else? Oh, man. So figuring out this signing and notarizing stuff, I did that on like Monday. That was like the first day of the week. And then I had a problem with the game running on macOS Big Sur. It ran on every other macOS version I could find, Catalina, what was the old one? El Capitan, all these different Macs, but not Big Sur. And it took me like all the way until Thursday morning to finally get it working. It was haunting my dreams, like literally. On Wednesday night, I was up super late and like couldn't sleep and couldn't stay asleep because just this macOS Big Sur thing was driving me crazy. But I did eventually solve it, so it should work on any of the recent versions of macOS. What else? I've done a ton of refactoring on the game. Previously, the game was basically in one mega scene that did all the things, and that has gotten split up into about 5, I think, main scenes. Yeah, match setup, practice, session setup, and title. This has made the code so much easier to understand and to reason about and to add new things to, particularly like the practice mode. I talked about this on the stream. I did another game dev stream on Friday where previously the practice mode was like a variable that got set, like we are in practice mode, yes or no, true or false. And then there was code just like littered throughout the project that was checking like, are we in practice mode, and like doing different things. And it was a mess. It was like 50 lines of code spread all over. It was very easy to break. And then when I split practice mode off into its own separate scene, it is now like 20 lines of code that are segregated to just this part. And it is so nice. And now the whole rest of the code base doesn't need to worry about practice mode. And the same kind of went for all of the different other sort of phases of the game. But this is sort of risky. I kind of put off doing it because I was worried about the risks. And it's risky because the game is built using Godot's high-level multiplayer API, which depends on all of the clients that are connected together in a match having the same scene tree. They all need to have exactly the same scene tree, which allows the different clients to make RPC calls to do things on the scene tree on other clients. And if they don't have exactly the same scene trees, like bad things happen. One client will think it's telling another client to do something, but it won't actually be going anywhere useful. And the client that's getting all of these, weird messages that don't make any sense, like won't be able to tell them. And when you're changing scenes, you're basically replacing like the majority of the scene tree. So there needs to be this dance whenever all of the clients need to change scenes for like a different thing that we're doing. They all need to do it together, and they all need to be done at the same time, or not at the same time, but they need to all be sure that they are all done before they start sending messages to each other. So I wrote this new little singleton to try and coordinate that dance. I'm pretty happy with it. At least I'm happy with the design of it. And I'm also happy that in all the playtesting that I've done with it, it seems to have worked fine. We haven't encountered any issues with it. It allows the host to say, okay, we're all going to change scene now, and it gets this host operation object back, and then it can connect to this completed signal or yield on it to know when all of the clients have said, okay, yeah, I've loaded that scene, I'm ready to go. And on the client side, they're given this client operation object when the scene is changed, and they're expected to do mark done when they're done, and then just wait for further instructions. And, it's basically aggregating all those mark dones to fire that completed signal. And so far this has worked. I'm worried that this could be a source of weird bugs and instability if it doesn't work. But on the upside, if we can get this code in here working well and stable and bug-free, like we won't have to really touch this very much. But then all the other parts of the code will now be easier to reason about and easier to work with. And those parts of the code we're going to be changing all the time to add new features and stuff. So the big refactor was there to allow us to have different game modes. And I'll show you how that looks. So we go to battle, we enter the matchmaking queue, find each other. So all this is exactly the same as it used to be. We say, I'm ready, I'm ready. And now we go to this new screen. This is the match setup scene where we can pick the game mode. So Battle Royale is what I'm calling the traditional mode, where you would do X number of rounds where you want to be the last tank standing. And you can adjust, how many of those rounds you need to win to be declared the ultimate winner. And then a new mode, which I'm calling deathmatch mode, which is basically a timed match, can go for 5 minutes or whatever you set this to, and whoever gets the most kills wins. And if there's a tie at the very end, it'll kill all the people who are not tied and just have like a instant death round between the two remaining players. And so let's just do this deathmatch mode really quick. You can see it's got a little HUD on the bottom, so you know who has got how many kills at what period of time. And we'll kill the other me. You can see the score goes up, the time's going down. But yeah, I think having the ability to have match modes is the most important feature for going to Steam, and it's in. And the ability, the adding of the match modes is actually pretty cool. I like the way that it works. I will show you. So we have a custom resource. Go to the modes folder here. So I have a custom resource class called match mode, which you then make these individual resources for it. So like, let's look at the Battle Royale resource. It has a name, a description, and then you give it two scenes, a manager scene and a config scene. So that's really, what makes them different. And if we go look at, for example, I don't know, the Battle Royale config scene, this is where the UI comes from when you go to this mode. So whatever different things you want to be able to tweak for this particular mode, you put them into the config scene, which then has some methods like just get config values. And those config values get passed to the manager scene, which isn't very interesting to look at least in Battle Royale. It's just a node with nothing on it. But this scene will be instanced into the game when it's actually running, and it will be in charge of starting the game, keeping score, deciding who wins at the end, and then ultimately exiting the match. So all of the kind of like life cycle of a match happens here. The deathmatch scene is more interesting because the deathmatch scene actually has that extra UI and the countdown timer and all that stuff is baked into this scene that's only ever instanced if we are in this particular match mode, which is hopefully going to be flexible enough for us to create all of the different match modes that we want to. And eventually, when I add modding, will hopefully allow other people to add new match modes. So I think that's all the things. What's up for next week? I know on the last video I talked about that this past week that just happened, I was going to work on polish and getting the game into a releasable state. Well, I didn't do that. I never got around to that. Instead, I did all the things that I just talked about. So this next week that's coming up is when I'm going to try and focus on those things. I'm going to add sound. I'm going to add music. I'm going to redo the UI. I'm going to make a new UI theme that's more attractive and I think fitting better with the art style of the game. And make a new title screen other than, this old Game Jam quality title screen that just has some text and some buttons. I'm going to make something nicer to go here. And that is what I hope to work on, and I hope to be showing you in a week for my next devlog. Yeah, that's all I've got. Thanks for watching. Talk to you later. Bye-bye.